Alright, so I haven't graded your tests from yesterday yet, or but I should have them done by the end of the day. So if you know your Skyward login and password, just look it up at the end of the day and you'll be able to see what you got. If you don't know that stuff, you can get it from Mr. Paralis, I think. So on Monday, you guys took some notes on quadrilaterals, like all the parallelogram, rhombus, square, rectangle, kite, all those. We're going to start doing some stuff with those now. I'm going to go over a couple problems with you, just kind of show you how to go through it, and then you're going to do the other two. I'm going to do the harder ones of the two and just kind of give you some pointers. So we'll do this today, and then tomorrow I'm going to try to show you how to make these cool little book things. I think I showed you guys this to help you study, to memorize all the definitions, like the definition of a rhombus. There's 3 things you need to know, and if you flip the page it gives you them, so you can kind of, so that'll be tomorrow. The reason you'll need to know those definitions is to be able to do these problems and do these problems well. As you'll see right now, we'll do the parallelogram one first. All this stuff in the middle is the stuff I want to find. You need to solve for x, y, angle D, angle C, side CD, and side AD. So let's just start here with x. X is in here in one of the angles. And so to be able to do these, like if you just look at this and you don't know what a parallelogram is, you might have no idea where to start. But if you know all the definitions of a parallelogram, it's actually pretty simple. Parallelograms have 2 sets of parallel sides, so those are parallel, those are parallel. The opposite sides are congruent, so these are the same length, and these are the same length. Opposite angles are congruent, that's one of the definitions. So that's the angles opposite from each other. So like this angle, angle A and angle C are the same, and angle B and angle D are the same. So that right there, that definition right there, tells us how to solve for x. If I know angle A and angle C are the same, well then I know that 3x minus 30 will equal 2x, and that's how I solve for x. So it's really pretty simple if you know all the definitions. So just solving for x here, I can go either way. I'll subtract 3x. So negative 30 equals negative x, divide by negative 1, boom, x is 30. On the quadrilateral one, it might be shown a little different. You should know, I don't know if you do, but the angles of a quadrilateral always add up to 360. You know how the angles of a triangle always add to 180? Well, for a quadrilateral it's 360. So like say that was an x there, say. Just pretend that we had 5x. Don't write this down. Say that was 5x, and I said solve for x. You can still do that, but another way you could have done it, you could have done, let's go up here, let's say 3x minus 30. So if I take that angle, plus that angle, plus 5x, plus that angle, plus 2x, plus that one, well that one has to be the same as that one, because it's a parallelogram, plus 5x. If I add those all up, it'll equal 360. Then I can combine like terms, solve for x that way. Like I said, if that was an x, and that's how it is on the quadrilateral one, so you might have to use that. But it's not an x. So we got x is 30, now we gotta get y. And to get y, we have to know more definitions about the parallelogram. I don't know which order they're in on the notes you took, but another one of the definitions is adjacent angles are supplementary. So we should know adjacent, what that word means, right? It means right next to. So that means any 2 angles right next to each other, like these 2, or these 2, or these 2, or these 2, are supplementary. And you learned in middle school supplementary means that they add to 180. Right? And then you also learned about complementary angles. complementary were ones that add to 90. So if I know that adjacent angles are supplementary, I know that if I add two of the angles together, I'll get 90. So that means if I take 5y plus this one or 5y plus this one, I should get 90. So I'll choose this one just because it looks easier. So if I have 5y, this angle, plus 2x, I should get 90. Or not 90, it's supplementary, 180. It's late, I'm tired. Well, I already solved for x, right? It was 30. So I know x is 30. So I got 5y plus 2 times 30 equals 180. Right? So that angle must have been 60 degrees. So 5y plus 60 equals 180. Subtract 60. 5y equals 120. Divide by 5. What's 120 divided by 5? 24. So y is 24. Now we got that one. Measure of angle D now. I kind of already did this. I mean, measure of angle D plus the measure of angle C equals 180. You could do it that way to figure this one out, because you know C. You could plug in x. 2 times 30 is 60. So angle C must be 60, right? Oh, I just gave you that one. Well, that was easy. That's 60, right? Because it's just 2 times x. So if these two are supplementary, if this one's 60, what's this one got to be? Of course, 120, right? 180 minus 60. Or right here, you had the answer too. 5y was equal to 120. Well, 5y is right there. That angle's 120. That angle's the same as that angle. CD. So this side, how long is? I think I'm missing a piece on my picture. I had to hand draw this because I forgot my copy of your worksheet at school. So yeah, yours has 8 inches right here. Well, so if you know the definition of a parallelogram, you know that this side and this side are the same length. So CD is 8 inches. And AD now, down here, well, I didn't make this worksheet, I'm not going to lie. So this, you can't figure out AD in this picture. There's not enough information. You gotta have something else. So you can't do that. So that's that one. Let's look at the kite. This one's a little harder. This one you're actually gonna have to use your SOHCAHTOA knowledge. And as we go through these, you're gonna have to use a lot of SOHCAHTOA, a lot of Pythagorean theorem. So it kind of continues on. That stuff isn't going to go away. It's going to be here for the rest of the year. Eventually, I'm going to give you this worksheet. There's like 9 problems with a ton of stuff to find. And yeah, I'll expect you to be able to do all of that. So these are just the first 4, I guess, example problems of how to solve all this stuff. I just did an example of a parallelogram. I'll do an example of a kite. You have the trapezoid and the quadrilateral to try after I get done with these, and next week we'll talk about those two, and then we'll do some other ones. Like I have the isosceles trapezoid. There's a whole bunch, and you're gonna have an example of all of them before I expect you to do them all on your own. So this kite, let's see. Got to know the definition of a kite. Besides the thing that has a string that you fly in the wind. Let's see. I got my definitions over here. It says adjacent sides are congruent. There's that word again, adjacent. That means the sides right next to each other. That's not completely true. Like in this picture, these sides are adjacent, but they're not congruent. It's these two are congruent. Huh. I don't like this. See, notice in the bottom left corner of your worksheet there's a definition. I don't like that. We'll talk more about that later. Let's see. Angles not attached to the long diagonal are congruent. That's okay. So what diagonals are? If you go at the vertices are like that's the plural form of vertex, and a vertex is like the corner. Every angle right there. Diagonals are if you draw a line between those corners. So a line there and a line there, those are called diagonals. Mine's a little off because I hand drew it. So it says angles not attached to the long diagonal. Well, that's the long diagonal. So the angles that are not attached to that would be here and here. So those angles are congruent. I'm going to put little things. If you ever see something like that, that just means that those angles are the same. The diagonals are perpendicular. That's going to help big time in this problem. Those are perpendicular. Remember, perpendicular means they intersect at a 90-degree angle. So all of those angles are 90. The long diagonal bisects the shape. So this one bisects, just means cuts in half, cuts into two equal parts. So this diagonal cuts it right in half. So now let's go through and find all this stuff. So angle B, we can start there. Actually, it doesn't matter where we start. We'll start with angle B. So to find this angle, well, I know it's the same as that one, but now what are we going to do? The hard part of this one is you don't know much, and it's going to be easiest to work with these right triangles in here. The reason that's easiest is because we know how to work with right triangles. We know SOHCAHTOA and we know Pythagorean theorem. So I know this side's 4. So I'm just going to look at this triangle right here. I'm not going to be able to get angle B right off the bat, I don't think, because we don't know for sure that that diagonal cuts that right in half. I might be able to find half that angle, but I don't think I can find the whole one. So I'm actually not going to be able to start with angle B. We'll start with angle C. Well, angle D is the same story. It's just over here. We know angle B and angle D are going to be equal, so once we have one, we'll have the other. So let's start down here with C at the top. I can figure out this angle. To figure out this angle, remember, one of the definitions said that the long diagonal bisects the shape. That means that this diagonal right here, this one going down, cuts this angle perfectly into two equal parts. That's nice, because now, if I just take this right triangle up here, if I can figure out this angle, just double it and I'll know angle C. So I'm going to draw a little triangle up there. I got that. That's my angle I'm looking for. I know this side is 3 inches, but I don't know anything else. Don't know this side, don't know this side. So I can't do SOHCAHTOA yet, because I don't have my opposite or adjacent. I only have the hypotenuse. So I'm kind of stuck. But if I come down here to this triangle, once again, this long one cuts the shape in half. So if the angle A is 50 degrees, I know this part is exactly half of that. So I got 25 degrees down here. At A, this side is 4 inches. Here's D, here's B. Well, this side on this triangle and this side on this triangle are the same, right? See that? It's right there. It's right in the middle of them. So if I can use this triangle to figure out this side, then I'll know this side and I'll be able to figure out this angle. So right here, you should be able to solve for x pretty easily. You know, you got a right triangle. Start with your angle. Hey, that's opposite hypotenuse. So I can do the sine of 25 equals opposite over hypotenuse. Boom, multiply by 4 and I got x. Let's see, 4 times the sine of 25. I need a calculator. And I get a negative number. If you do something like this, like I did 4 times the sine of 25 and I got a negative number, obviously that's wrong. Your calculator has a setting for radians and degrees. Radians is another way to measure angles. You'll learn about them in pre-calc. You want to make sure you're in degrees. The way you change it is different on all calculators. I can show you if that ever happens on your calculator. Most of them, there's a button that says like DRG, I think, and you push it and it changes. But anyway, so 4 times the sine of 25 is 1.69. So So now I know this side was 1.69, so I know this side was 1.69. Now I can find theta. Because I have opposite hypotenuse, I can do the sine of theta equals 1.69 over 3. And then of course inverse sine both sides of 1 point, oops, it's hard to write when the paper's moving. 1.69 over 3. Type that in, inverse sine, and it's 34.29 degrees, or we'll say 34 point, let's round it up, 34.3 degrees. So that's here. So if that is 34.3, then angle C is just double that, so 34.3 times 2 would be 68.6 degrees. So I finally got one angle. Now I can actually get the other two angles. If I know this one, I know this one, I know those two are the same, and I also know for a quadrilateral, all of the angles add up to 360 if you add them all together. So if I take this angle, my 68.6 plus down here my 50 plus this one plus this one, well, let's call it, I don't know, we can call it x, y, whatever, but there's two of them, so plus 2x will equal 360, and just solve that. So combine like terms, I got 118.6 plus 2x equals 360. Subtract 118.6 from both sides. 2x equals I'm going to use my calculator because my brain is working. Probably going too fast anyway, so good to slow down a little bit. 241.4, and then just divide by 2, and you got x equals 20.7. So what was that? What did we just do? We solved for one of those angles. If we got one, we got the other. They're the same, so they're both 120.7 for measure B, measure of angle B, and measure of angle B. And mine's all messy in here because I wrote, but hopefully yours will be nicer. So I got all my angles, now I just got to do some sides. Let's see, let's go with AB. That's, oh, that was easy. It's already done. It's the same as this side, right? It's got two little tick marks. That's the definition of a kite. If this side's 4 inches, this side has to be 4 inches. BC, same thing. One tick mark, 3 inches. That one has to be 3 inches. Let's see, BD. It wants the measure of the diagonal. How long is the diagonal? Well, we pretty much already did that. Because remember we found this bottom part of that triangle right there, 1.69. Well, remember that diagonal cuts this in half, so if that's 1.69, so is that. 1.69 times 2 should be like 3.38 or something like that. 3.38. And then we got AC, the measure of the long diagonal. That one we haven't done yet. That's going to take some work. But, you know what, I'll actually just leave that one for you. Because look at, you got a right triangle right here. This top one. You know, two sides, you could just do Pythagorean theorem if you wanted to get this side. You could do SOHCAHTOA using that angle, whatever you want to do. But if you get this side of this triangle and this side of this bottom triangle, add them together, that'll be AC. Right? So down here you can do SOHCAHTOA. You can do, you know, whatever you want. SOHCAHTOA or Pythagorean theorem. Get this one, add them together, get AC. So do that, and then give the other two a shot. That quadrilateral and the trapezoid. I think those two are probably easier. I mean, there's less stuff. So hopefully you can figure those out, and then tomorrow I'll try. I still gotta figure out how to make the books. See my Lucky Charms there I just had, but yeah, you'll make those. So that's all I have to say about that. Have fun with this. Don't be scared. You know all this stuff. It's just a matter of figuring out when to use what and whatnot. So have fun.